Step into the Coliseum of Cambridge exams. Look around. Only the prepared survive in here. Welcome to this high-stakes strategic explainer, where we are stepping directly into the arena of Cambridge AS and A-level mathematics. Specifically, we are targeting syllabus 9709 and the notoriously difficult, often dreaded topic of partial fractions. Whether you're dealing with linear factors, repeated factors, or those incredibly tricky quadratic factors, this is the battleground where your grade is decided. In my years of analyzing Cambridge exams, I always see two types of candidates enter this arena. First, we have Alex. Alex overloads their answers with raw mathematical facts, memorized formulas, but absolutely zero contextual analysis. Then we have Sam. Sam rushes, entirely missing the specific command word requirements of the question, and bleeds marks because of it. Today, we aren't just looking at the math. We are looking at the exact strategies, the procedural frameworks, and the theoretical foundations you need to stop making Alex and Sam's mistakes and start mastering the examiner's mind. Okay, let's dive into this massive warning directly from the senior examiner. This quote reveals exactly how high the stakes are for this specific mathematical topic. The principal examiner reports consistently highlight that partial fractions stand out as a uniquely misunderstood area of the entire algebra syllabus. Why? Because students often treat this topic as a mechanical chore. They think it's just about shifting x's and y's around a piece of paper. But examiners are looking for something much deeper. They are looking for logical architecture. If we were to look at Alex and Sam's flawed answers side by side with the examiner's red pen marks, you'd see exactly what I mean. Alex loses method marks for failing to set up the correct initial identity, while Sam loses accuracy marks for completely ignoring command words like hence or show that. We are going to fix that misunderstanding right now by showing you exactly what top-tier, examiner-approved algebraic processing looks like. We really have to ask ourselves this crucial question, because crossing the bridge from rote textbook memorization to contextual exam application is where the battle is truly won or lost in Cambridge mathematics. When a question looks slightly different from the homework, perhaps integrating partial fractions with another syllabus area like binomial expansion or complex integration, many candidates just absolutely freeze. They struggle because they lack the conceptual framework to adapt. They've learned the steps, sure, but they don't understand the causal relationships behind why those steps actually work. When you don't know the why, an unfamiliar context will crush you every single time. Here is our battle map for today's explainer. This structure is specifically designed to move you from isolated, fragmented facts to complete, examiner-level mastery. We'll cover the partial fractions challenge, core principles, the procedural framework, those critical examiner warnings, the method mark strategy, and finally, our ultimate problem-solving sequence. Let's get right into it. Section 1, the partial fractions challenge. This brilliantly illustrates the fundamental difference between surviving and thriving. Failing students rely on generic, isolated facts. Let's think back to our student Alex. Alex sees a fraction, instantly guesses a setup, and hopes for the best without critically analyzing the denominator first. Is it a proper fraction? Is it improper? Alex doesn't check. Sam, on the other hand, just starts doing long division without reading the command word. Top-performing candidates take the winning approach. They use cross-topic connections, they decode the command words, and they use evidence-based reasoning. They recognize immediately whether they are dealing with a linear, repeated, or quadratic factor, and they understand how that algebraic structure integrates with the rest of the syllabus. It is this analytical depth, this split-second recognition, that captures the highest tier of marks. Section 2, Core Principles and Connections. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, so the crucial point here is that Cambridge benchmarks prioritize analytical depth over superficial breadth. They reward students who can integrate partial fractions with other areas. Now, you've probably heard of the Peel framework for essay writing, right? Point, evidence, explanation, link. Well, top students use a mathematical version of Peel. Your point is decoding the command word and setting up the correct algebraic identity. Your evidence is extracting the coefficients or choosing the right values of x to substitute. Your explanation is your crystal clear step-by-step algebraic working. And your link is tying that final partial fraction back to the original context, like using it to evaluate an integral. If you can reference these cross-topic connections, you demonstrate the exact transferable understanding that examiners are desperate to reward. Section 3, the procedural framework. Now it's time to arm ourselves with the exact weapons we need to tackle these examination questions systematically. This 5-part standardized sequence is your transformation blueprint. It guarantees methodical, reliable problem solving. Imagine a 60-second timer ticking down in the exam hall. Step 1, identify key elements. Specifically, check the degrees of the numerator and denominator. Are you falling into the improper fraction trap? Step 2, apply relevant principles. This is where you write out your identity. Step 3, execute the analysis. Equate those coefficients or substitute your strategic x values with absolutely clear notation. Step 4, verify your results. Do your constants actually make sense? And step 5, present in the appropriate format. Never leave your answer as just a equals 2 and b equals 3. Rewrite the entire fraction. This sequence is how we take the red pen marks on Alex and Sam's papers and transform them into green check marks. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, Section 4, Top 3 Examiner Warnings. Let's navigate the traps by looking at the highly classified principal examiner reports to see exactly where students bleed marks. Challenge time. Let's do a quick find the flaw exercise. Imagine a student is given a fraction where the numerator has an x squared and the denominator expands to an x squared. They immediately set up a over linear factor plus b over linear factor. What's the flaw? Exactly. They confuse cause and effect in their methodology. They applied a rule for proper fractions to an improper fraction without doing polynomial long division first. That's trap number 1. Trap number 2 is forgetting format and presentation. Messy working where your plus signs look like T's or skipping lines of working out will cost you method marks. But the ultimate trap is providing a generic answer. If the question says, hence, find the exact value of the integral and you just provide the partial fractions and stop, you've completely ignored the context. Section 5, the method mark strategy. We are now entering the scoring zone. Let's do a 60-second visual data scan. Look at how this table systemizes the math, showing how different factor types demand totally different analytical approaches. For linear factors, your strategy focus is precise definitions. You need one distinct constant, like a, over each linear factor. For repeated factors, like an x minus 1 all squared, the focus shifts to causal relationships. You absolutely must understand why you need an a over x minus 1 plus a b over x minus 1 squared. If you miss the single power term, your entire method mark strategy collapses. Finally, for quadratic factors, and I'm talking about unfactorable ones like x squared plus 3, your systematic analysis has to step up. The numerator must be a linear expression, ax plus b. If you just put a single constant, a, over a quadratic factor, the examiner stops grading your working right there. Understanding these boundaries secures your M1 and A1 marks. To lock this all in, I highly recommend creating your own memory mnemonic. Let's use the first letters of these 5 tactical steps to build a mental cheat sheet. D for deconstruct, E for extract, S for select, E for execute, and P for present. D-E-S-E-P, DESEP. Let's do a 30-second speed writing visualization. The exam pressure hits, you turn the page, and you see a massive algebraic fraction. Don't panic like Alex. Use DESEP. Deconstruct what command words are used. Extract the algebraic degrees. Select your linear, repeated, or quadratic framework. Execute your equating of coefficients. And present your final fraction beautifully. It is a foolproof safeguard against exam anxiety. Section 6. Deconstruct, solve, evaluate. Finally, let's look at the ultimate victory framework that examiners are desperately searching for in top-tier answers. This is your comprehensive answering system. It boils down to 3 rules that guarantee top marks. Rule 1. Command word decoding. Are you deconstructing the actual question being asked? Rule 2. The Peel framework application. Are you solving systematically, showing your point, evidence, explanation, and link? Rule 3. The time management matrix. Are you evaluating your answer quickly to ensure it's reasonable without burning 15 minutes on one algebraic check? If you recombine your partial fractions in your head, do they actually return to the original expression? This evaluative step ensures that every piece of your mathematical reasoning is bulletproof. As we wrap up this explainer, I leave you with this final challenge. Academic benchmarks for Mathematics 9709 require logical, structured reasoning. Are you just going to rely on rote memorization, crossing your fingers and hoping for a standard textbook question? Or are you going to use this methodology to master the examiner's mind? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.